have your attention now, please? Now, this is our original stiffness matrix equation, B equal to, or K equal to B, E, B, E, E, B. For this one here, you need to take the partial derivative of your shape function with respect to x1 and x2. But instead of using this one, we're going to have a different expression here. Instead of taking the partial derivative with respect to x1 and x2, we're going to take the partial derivative with respect to c1 and c2. So to be able to do that, we need a Jacobian, which is this one here. So this one, we will have an expression for this one here, partial n with respect to c, and we will have an expression partial x with respect to c1. So looking at this next slide here, so there you go. This one is very standard for a quadrilateral element. Very standard, no memorization needed. It's just following this equation here. So partial n1 with respect to c1 is equal to this one here. If you have this value, then this one will simply be another number. So you don't really need to take the derivative already because it has been taken for you already. So you can take the partial derivative of this one with respect to this. But you'll definitely end up with this one anyway. So this one is just a mere number. We'll be able to know this one depending on your integration assumption. This will just be another number. It's either 0, negative 0.577, or positive 577, depends on your assumption. So the same is true with this one here. Since you have this one here already as an equation, then just substitute in the values. So you will have 1, 2, 3, 4, 5, 6, 7, 8 values already for this one. Straightforward solution. What about this J11, J12, J21, J22, which is given by this one here? You'll have another set of equation for that, which is given by this one here. So J11 is equal to this one here. Again, you will be dependent on your assumption here. C1, C2. So that's J11, J12. You have these coordinates. X11, X1 at 2, X1 at 3, X1 at 4. These will be your coordinates from your original quadrilateral element. So to be able to map this one, you need this J11, J12, J21 values. So this is where your coordinates will come in. Okay, and this is just another number. So as you can see later on, you will come up with a number here. So J11, J12 is this one here, and so on and so forth. So these equations are pretty much standard already. So once you have this J values substituted here, take the inverse, substitute it here, determine these values which we can determine from this one, and you get now your values for your B matrix. So let's have an example. So I'm looking at question 24.8.1 from your text. Can you have a look?
But always his answer and this answer was different.
Yeah, I think this one is one doctor, then that one is
Then how to study?
you see which one easier for you to understand.
You need to decipher.
Do you have it with you? So the next thing you would like to know is this one here, just previous to that. Do you have it? So this one, N1 or N2, will depend on your order of approximation or number of loss points. So you can read that from the previous example. This one is your weight function. If you say have N equal to 1, then your weight is equal to 2. Then your C1, C2 will be equal to 0. If you have your number of Gaussian quadrature to be 2, your weight will be 1. And the value of your C1 is negative 0.577. And your C2 will be positive 0.577. Okay, I'll explain later. So, for this one, for this example, so let N equal to 1, so that your C is 0, 0, meaning that C1 is equal to 0, and then your C2 is equal to 0, and your weight is equal to 2. So this is specific for this example only. So you can use the different value wherein N2 is equal to N is equal to 2, weight is 1, and C1, C2 will be negative 0.577 and positive respectively. So, the first step that you need to do is to determine your Jacobian. You have a value for your Jacobian, right? Or you have an equation for that Jacobian. So let me flash that equation. So anyway, the solution is there. So let me flash the equation. Yes. Your Jacobian, so the first step, as mentioned in your notes, is to determine your Jacobian matrix. So you need to determine J11, J12, J21, J22. Yes? So here, partial N1 with respect to C1, you got that already. So no change here. You don't need to take the derivative of your shape function 1 with respect to C1 because that has been done already. X1 at 1 is your coordinate. X1 at node 1. You have X1 at node 2, X1 at node 3, X1 at node 4. Now, we have your Gaussian quadrature N equal to 1. So what will be the value of C1 and C2? What will be the value of C1 and C2? They will both be 0. So it's difficult to transfer from one to the other, so apologies for that. This will be my x1 at 1, node 1, x2 at node 2, or sorry, x1 at node 2, x1 at node 3, x1 at node 4. My C1 is 0, C2 is 0. Why? Because I use this assumption. This is very standard for n equal to 1. If I have my Gaussian quadrature n equal to 1, then my C1 and C2 will be both 0, and my W weight function will be equal to 2. So no change here. This is standard for n equal to 1. And we're using this assumption. So my x1 at 1 is 2, x1 at 2 is 5, x1 at 3, 4, and x1 at 4, 1. So I can have now a numerical value. So let me flash that equation here. So what happens now? So what will be x1 at 1? Yeah, so you have there 2. What will be C2? 0. So you get a number for this one. It's the same. This one is 0. x1 at 2 will be your coordinate at node 2. 5. This one is 0. Okay. This one is 0. This one is 4. This one is 0. This one is 1. So you get a number for J11. So the equation looks daunting, but actually it's very easy. Yes? So you get now a value for J11, J12, J21, and J22 by simply following these equations. Yes, so here you go. You have now this one here. The value of C2 hasn't been placed in there yet. But if you're going to be using N1, n equal to 1 as your Gaussian quadrature, we can have now your C1, C2 to be both 0. So your J11 is 1.5. So following the same procedure, you have your equation for J12 using C1, C2 equal to 0, J12 is 0.75, and so on and so forth. You get now this value here. How about that? So this is now your Jacobian matrix, and it is a definite matrix, meaning the values, numerical values can be calculated. So you have a way to take the inverse of this Jacobian matrix. Take the adjoint divided by the determinant. So you get now your inverse of the Jacobian. And the value of your Jacobian is simply taking the determinant of your Jacobian matrix, which is 3. So you will use this number later. So you get your Jacobian value as well as the inverse of your Jacobian matrix to be this one here. Okay, so after determining your Jacobian matrix, inverse of the Jacobian, and the Jacobian number, what's next? So you take your straight displacement matrix. So what are the values that you need for your straight displacement matrix? It's simply these 8 values here. Partial N1 with respect to C1, partial N2 with respect to C1, N3 with respect to C1, and so on and so forth. So you don't have to take the derivative already because the equation is fixed, shape function is fixed for quadrilateral element. All you have to do is to plug in your values for C1, C2. So what is the value for C2 here? 0. So minus 1/4 multiplied by 1. This value is simply equal to minus 1/4. Straightforward, isn't it? So you're just following equations here. So the equations here are very daunting, but really, it's so easy once you have done one round on this one here. Yes?
Spend go by credit. You see 10 credit means 1.5.
So let's try to move here.
That will be going to easy with
Confirm is different.
So this one is your strain displacement matrix, partial of n with respect to x. So this one can be solved using this equation here. You have the inverse of the Jacobian and the partial derivatives of n with respect to c's. Partial n1 with respect to c1 and so on and so forth. So you will be able to get those values. These are all given. So if this one's C1 and C2 are 0, then this one can be further simplified. So this is the inverse of the Jacobian. You got your J1, J2, J12, J21 already. Take the inverse of that matrix. And then you have now these values here. So you can substitute your assumption now since you're using n equal to 1. C1 and C2 are both equal to 0. Substitute the values here. So you're going to end up with this one here. So not anymore so scary. Okay, because C1 and C2 are both zeros, then you can now simplify this matrix to this one here. So not anymore so scary. Right? So simply perform matrix multiplication and you get these values. So once you get this one equal to that, this equal to that, this one equal to that, this one equal to that, you can complete now your strain displacement matrix transpose 3 by 8 using this matrix equation here. Yeah? So not anymore that scary because all of these can be calculated using equations that you have already. You don't have to perform derivation or integration. What about your E matrix? Depending on your assumption, you can use your plane strain assumption or your plane stress assumption. You can calculate for this one. Next, once you got your B, once you got your E, once you have your B, once you have your E, you can now perform this one. Again, you don't have to integrate here. don't have to perform integration here because you already have your Gaussian quadrature assumption n equal to 1, C1 equal to C2 equal to 0, and then your weight is equal to 2. So that is W1 equal to 2. So we can simplify this one to be equal to K, summation of I equal to 1 to N. We only have 1 here. So this one is Wi, W1. So let me just put there W1. You have your function of Kasi, your thickness multiplied by that Jacobian value. The number, not the matrix. So what is our Jacobian matrix earlier? Jacobian value, sorry, that number. What is our Jacobian number? If I go back here, this one is equal to the determinant of J. So this J there is the determinant of your Jacobian matrix equal to 3. What is your thickness? You have a unit thickness that is equal to 1. So what is this function here? This function is simply your B. So here you have to calculate here. B transpose. So you have an 8 by 8 matrix. This one is 8 by 3, 3 by 3, 8, 3 by 8. So you have this one to be 8 by 8, which you have already calculated. And what about this one here? This one is simply equal to 2. So since I is equal to 1 to n, then it's just simply 2 multiplied by this equation, multiplied by 1, multiplied by 3. So what do I mean by that? So here you go. So previously you have now this equation here. Yes? You have this equation here. So once you have your n equal to 1, so take note, just going to write it here. Your k will be equal to summation I equal to 1 to n, Wi, function C, thickness multiplied by your Jacobian value. So since n is equal to 1, so this one is that W there too. This will be your thickness there, and this will be J. So this will be your function C. That's simply 2, because your W is equal to 2. You already assume that n is equal to 1, so your W is equal to 2. N is equal to 1, so not a problem anymore. So just one round of integration instead of iterating. So this one is I equal to 1 to 1. So you don't have to iterate twice or thrice. And then this one is your thickness, and this one will be your J equal to 3. So this one is your function of C, which you have solved numerically already. So there you go. This one will be your B, E, B, E. That is your W equal to 2. This will be your thickness, which is equal to 1, and this one is equal to 3. So simplify this one. You have now your 8 by 8 stiffness matrix.
This is 3 by 8. 1, 2, 3, 3 by 8.
Yeah.
It's 2 by 3. It's messed up.
So any questions there? Any questions?
No, sir.
So the question is, what if we want to use n equal to 2?
2.
Your C1 is negative 0.577 first, and then your C2 will be positive 0.577. So what's going to happen? Okay, let me repeat what we did. So this is our general equation, right? So what is our first? So what do we do first? First we determine your Jacobian matrix J11, J12, J21, J22. Yes? So this is what we do first. The reason for this one is we want to determine that B. So we want to have your Jacobian matrix, and after that we can determine your Jacobian value. So this will be equal to, sorry, I missed that J there. J will be the determinant of your stiffness, of your Jacobian matrix. Yes? So here, you can straightforward determine your B matrix. So once you have that, you can have now a value for B, E, B transpose. Because E, you can simply use a plane strain, stress, or plane strain assumption. So how do you integrate? You are able to integrate by first assuming your Gaussian quadrature. So just accept that that's a name. So you have now here n equal to 1. If you have now your Gaussian quadrature to be n equal to 1, you have now your C1 equal to C2 equal to 0. And your weight is equal to 2. Say weight 1, because n1 is equal to 1. N is equal to 1. So you can have now your k equal to the summation from n equal to 1, or sorry, I equal to 1 to n. You have now your weight, say I, and then you have now that function C1, C2, does it matter? You have now your thickness, you have now your J. And this one will be your B, E, B transpose. Now, what happens if you have n equal to 2? So say for example, we did this one if n is equal to 1. That's straightforward. K equal to summation I equal to 1 to 1, doesn't matter anymore. So this one is equal to 2. This one is simply your shape function, or sorry, your function wherein C1 is 0 and then C2 is equal to 0. And then this one will be your thickness and your Jacobian. So what if you have n equal to 2? What will happen? So we will do this one next meeting. Just telling you that if n is equal to 2, so you have your C1, C2 equal to plus minus 0.577. And then your weight 1, weight 2, so I'm just copying now the values here, will be both equal to 1. Sorry, weight 1, both equal to 1, sorry. So what else do we need? So nothing. So what you're going to do here, your stiffness matrix is equal to the summation of I equal to 1 to n. And then this one is Wi. You have your function C, and then you have your thickness J. So that this will be W1. So this one you have to do it twice, wherein your function initially will be minus 0.577, negative 0.577. This will be C1, C2. So you have to input this one. It's not anymore 0. And then you have your thickness and your Jacobian based on these two values. Next, I is equal to 1 to 2. So you have now your W2, your function. This one now is 0.577, 0.577. This will be the C1, C2, thickness multiplied by that J, depending on these two values. Where in W1 is equal to 1, W2 is equal to 1. So meaning that you have to take these values twice. So what happened here is that when we have C1 and C2 to be 0, we just did it once. You take your B, E, B, T, or your B to be C1, or based on C1 and C2 equal to 0. But now, you will have now your function yes, this one is C1 and C2. So what will be your B? What will be your Jacobian? Sorry. I'll start with the Jacobian. What will be your Jacobian? What will be your B? If you have your C1 and C2 to be 0.577, so this will be C1 and C2, what will be your Jacobian? What will be your B? So, the more number of Gauss points that you use, N2, N3, N4, and so on, the more accurate your solution will be. But take note that when you do this one, then you have to spend more time in calculating it. So this one is numerical integration. You don't need to really integrate this one. Okay. The more number of Gaussian points that you use, the more accurate your solution will be, but the more calculation time. Because you need to determine your Jacobian for these 2 points and your strain displacement matrix using these 2 points. Okay, and then you move on, determine your Jacobian and stiffness or strain displacement matrix using these 2 points. So that is when n is equal to 2. So take note that when n is equal to 1, you just need to determine your B and your Jacobian based on these 2, C1 and C2 equal to 0. Yes? So that's a finite element using one unilateral element. Any questions?
No.
So this is how the computer calculates for the stiffness matrix. So instead of using the XY plane or X1, X2 plane, they use the C1, C2 plane because it's more convenient. Because once you put in all these equations there, then the computer will just take in these values, calculate, and come up with different values. Any questions for this one? So please have a look at the examples. Let's try to solve some more problems next meeting. Any questions? Questions, anyone? It will be easier for you, trust me, it will be easier for you to be able to understand this one if you just go one round. Just try one example and definitely you're going to get it. Okay? So let's try to solve an example next meeting. So if there are no questions, then you can go. Thank you very much for coming.
Thank you very much.
Attendance, please. Where's that attendance, please?
So low. I miss 2 already.
You miss 3
Huh?
3. You put A. 2.
It's 2 what?
2
Hi, that's why I never sign.
I sign for you already lah.
I want C.
新锐我拿回家。
You see, I never see my A. I haven't finished that.
Yeah, cannot.
Huh?
I for A.
Oh, yeah.
For A.
Why you never put me A? This is what the fuck?
You want him to put A man?
Huh?
You want him to put A man?
No lah. 不是我塞的，是赵东帮我塞的。我拿一个就是用我不懂我有没有塞。要pass 给谁？
他给老师啊。
哎 Ben，
哪里？触到。Pull into liquid aeroplane.
Is it?